Hello and welcome back. In this lecture I want to talk about file positioning, basically some functions that will allow you to change the position of a file. So for many applications you're going to need to be able to access data in a file other than sequential order. Sequential order is starting at the beginning and then going byte by byte towards the end. That's not always useful because you may want to actually go into the middle of a file and grab data, or at the end of the file and grab data. It all depends on the application. You don't always want to go from the beginning to the end. So there are various functions that you can use to access data in random sequence. There are two aspects of file positioning. One is finding out where you are in a file, and the other is moving to a given point in a file. Those are really the two things you want to find out when you're talking about files and the positioning of a file, what it's actually pointing to. Again, where you are in the file itself and whether or not you want to move somewhere else in the file. So you can access a file at a random position regardless of whether you open the file. You can move your file pointer. You don't need to open up the file to change where you are, to see where you are. So finding out where you are, we're going to talk about first. You have two functions to find out where you are in a file. One is called ftell and one is called fgetPOS, fgetPosition. For ftell, the actual function definition is pretty straightforward. You return a long and you take a file pointer. And this function is going to accept a file pointer as an argument, and it will return the long integer value that specifies the character position in the file. So it's going to tell you the position. You can use it by creating a variable, in this case fPOS, which is what's going to get returned, and then passing in that file pointer and calling ftell. The fPosition variable now holds the current position in the file, and you can use it to return to the position at any subsequent time. All right, so it's going to return you fPosition. This is the way you can get the position of the current pointer, where you're pointing to. The value is the offset in bytes from the beginning of the file. Okay, so ftell, very straightforward to use. Pass in your pointer. It's going to return and tell you where you are in your file, based on basically from the beginning of the file until how many bytes from the beginning. So in this example, we're creating a file pointer called fp, and we're creating an integer called length. We're going to open up the file, and this would be for reading only. We're going to make sure it's not null. If it is, we're going to return an error. And then don't worry about the fseek. The fseek is actually just going to go to the end of the file. This is another function that helps us. I'm only using it to demonstrate the ftell. Fseek is going to go to the end of the file, and then you're going to say ftell fp, and that's going to tell you you're basically going to be at the end of the file. So the length that's returned is at the end of the file. And so what's going to happen is it's going to return the total size of the file based on length, because you actually moved your pointer to the end, and then you said, where am I? And it said you're at the end, so it returned the end. And the end is the number of bytes from when you last read. So let's take a look at this inside of our nice IDE, our code blocks. So here's our coding example where we create our file pointer. We set it to null. Make sure it's not null. We try to open it up. And then we do an fseek, which is just going to change our file pointer. Ftell is going to tell us where we're pointing to. So it's going to point to the end, and it's going to be any number of bytes to the end. When we run this, what you're going to notice is it displays 24 bytes. So that means you're at the end of the file, because the file is a small file and the file only contains 24 bytes. Typically you'll use ftell after you've done some writing or reading, or after you did an fseek where you moved somewhere. But it's very simple to call ftell with the file pointer, and then len just tells you where you are. You can also use the fgetPosition or fgetPOS function, and this is a second function providing information on the current file position. It's a little more complicated than ftell. This returns an integer. It takes a file pointer, and it also takes a fPositionT type. So the first parameter is that file pointer, so you know what file you need to read to. The second parameter is a pointer to a type that is defined in standard io.h. The fPositionT type is able to record every position within a file. So fgetPosition function is designed to be used when the positioning function fsetPosition. So you'll use fsetPosition, and then you use fgetPosition in combination with that. So the fgetPosition function stores the current position and file state information for the file in position and returns 0 if the operation is successful. It returns a non-zero integer value for failure. So you can create a variable of fPosition type, and here we say it's just here. Then we call fgetPosition, we specify in our file pointer, and we specify in our fPosition type. We have to pass in the ampersand, the address of, because it's not a pointer. So in this case, the current file position is in the variable hello, or here, sorry. So you have to declare a variable of type fPositionT, because that's what you pass in your parameter, your second parameter. You can declare a pointer of the type fPositionT star, because there will not be any memories associated to store the position data. So let's look at an example. This will make a lot more sense. In this case, we create our file pointer, we create our fPositionT type position, we call open, and then we call fgetPosition. And we pass in our file pointer and our and position. Right, so that's where we're storing the position. We're going to get the position where we're at. Then when we say fputS, we're writing some data to wherever we move to. So again, fgetPosition and ftell tells you where you want to actually write to or read from. It's somewhere in the middle. It's not at the beginning. It's not at the end. You're moving. You'll usually move with a seek, or you move with something else with fgetPosition, and that tells you where you're at. So fgetPosition and ftell is going to tell you exactly where you're pointing to, and that means you can move somewhere else and you'll be able to read. Now, setting a position in a file, up until this point, we're just reading in where we're at. We're not going to really read in where we're at unless we set something. We did a read and write. So as a complement to ftell, you also have fseek. And fseek is going to allow you to move somewhere for your position. It returns an int, it returns a file pointer, a long offset, and an integer original. The first parameter is a pointer to the file you are repositioning. The second and third parameters define where you want to go in the file. The second parameter is an offset where a reference point specified by the third parameter. The reference point can be one of three values that are specified by the predefined names: seek set, seek current, and seek end. Seek set defines the beginning of the file, seek cur defines the current position in the file, and seek end defines the end of the file. Okay, so for a text mode file, the second argument must be a value returned by ftell. So you should notice that with fseek and ftell, they're used together. Okay. So the third argument for text mode files must be seek set. For text files, all operations with fseek are performed with reference to the beginning of the file. For binary files, which we haven't really learned much about, but for binary files, the offset argument is simply a relative byte count. You can therefore supply positive or negative values for the offset when the reference point is specified as seekcur. So let's look at an example. Here in this example, again, we do the fputS, so we write some data to our file, and then we use fseek. Fseek is going to move you. Here, this is saying you're going to move 7 bytes, and we use seek set to say we want to move somewhere, basically 7 bytes from the beginning. And we can move from the beginning of the file by 7 bytes. That's going to move it. After 7 bytes, we can then actually write data to it. And we would also be able to use ftell to see that, after 7 bytes, where we are. You can use the information to retrieve back from where you are. Again, the whole point of the fseek and the fgetS is you're either seeing where you are located to specify where you want to write to or read to. So fseekS is actually going to move the position. Tell is going to tell you where you are located. fsetPosition is also like fseek, but fsetPosition is a little more complicated. It will go with the fsetPosition. So fsetGetPosition is also very similar to fsetPosition. With the fsetPosition, it specifies the first parameter as a pointer to the open file. The second parameter is a pointer of the fPositionT type. The position that is stored at the address was obtained by containing fgetPosition. So fset position has your file pointer and then your actual variable. And the variable here was previously set by a call to fget position. Right? Again, you're going to use fset and fget together. The fset position returns a non-zero value on error or 0 when it is successful. This function is designed to work with a value that is returned by fget position. So you can only use it to get to a number in a file, to get a place in the file that you have been before. fseek allows you to go to any position just by specifying the appropriate offset. So here we look like we have our f position t type position. We open up our file and then we call fget position. In fget position, we're specifying where we want to move the pointer, where we're actually reading or writing in the file. Then we use fputS to wherever we moved it to. And then fset position is going to again set something specifically where we want to write to and then write it from wherever we want. So with all these functions, you want to actually see where you're pointing to. This will become way more easy to understand once we have our challenge. So with reading and writing, you always want to move somewhere to the pointer that you're writing to. You don't always want to write for the beginning or the end. And so these functions are very useful to move where you want to position anywhere in a file. Thank you.